The C++ reference type is a lot like a pointer, but with some significant differences. So if you haven't viewed the lesson on pointers, please take the time to do that now. This lesson will make a lot more sense if you understand pointers first. Here in Xcode, I have opened the copy of working.cpp from the lesson on pointers. I'm going to delete these last two blocks here, and we don't need this hello world either. And I'm going to delete this version of y, and I'm going to create a y that's a reference, int ampersand y equals x. So ampersand y, just like the asterisk before the IP above makes that a pointer, the ampersand before the y on line 9 makes y a reference. And so y is a reference, and it's initialized with the address of x. So remember, a reference is very much like a pointer, but it has some significant differences. One of the differences is this right here. You cannot define a reference without also initializing it. When you define a reference, you must say what the reference is a reference to, and in this case, it's a reference to x. So throughout its life, y will always be a reference to x. And anytime you use y, it's exactly the same as if you're using x. So I'm going to go ahead and change this order so that it's the same as well, and we'll save this and run it, and you'll see that x is 7. What's pointed to by IP is also 7, and y is also 7. So you see how we're using y. We don't have to dereference it like we do with a pointer. It doesn't need an asterisk in front of it or an ampersand or anything. We just use it as if it were a variable. Yet it's a reference, and it's exactly the same as x. So if I take another block of these, and I come down here and I say x equals 42, and I build and run this, you see that now x and y are all 42. I'm going to take this and copy it again, and instead of assigning x, this time I'm going to assign y, and we'll make it say 73. And when I run this, our third block, everything is 73. So we can use y just as if it were x, and it has exactly that same effect. I'm going to come down here and I'm going to make one more block. And here we're going to define a new variable, z. We'll give it a value of 149. And I'm going to say that IP equals the address of z. And now when I run this, you'll see that z is 149. What's pointed at by IP is 149, and x is 73, and y is always the same as x because it's a reference to x. Now, a reference is effectively immutable. Once it refers to a variable, it will always refer to that same variable. If I come down here and make a whole other block of these, if I come down here and I say y equals z, it's not changing the reference. It's simply copying the value of z into the variable that's referred to by y, which is x. And so when I run this, you'll see our last block here, x is now 149 also. References are used a lot in C++, especially in functions and classes, which we'll get to later. You'll see many more examples of this in the rest of the course. So for now, just file this away and understand that this is how references work. And we'll go ahead and we'll delete this working copy, and we'll run clean and clear out our console.